Hello everybody, my name is Kundinger, and in this video I'm going to tell you all you need to know about carbon fiber. So for starters, let's discuss what exactly carbon fiber is. Carbon fiber is exactly as it sounds. It is a material made up of very small strands of solid carbon that are woven together to make a shaped material, and then after being woven together, many of the carbon fibers will be sealed into shape by adding a coating with materials such as an epoxy, a polyester, or a nylon, or etc. And that prevents potential wear from any outside elements such as oxygen that could get into the carbon. Carbon fiber comes in multiple different types and forms. Each type of carbon fiber is based on two different qualities. It's based on the strength of the weave and the concentration of the carbon in the fiber. So carbon fiber is a very innovative material that has been used more and more as the years have passed, and it's used in a lot of modern designs, some of which include aircraft, vehicles, air turbines, and even sporting goods, like you see in the picture there. It's used in hockey sticks now. Designers of these machines use carbon fiber solely because it is a strong material while being very lightweight, which makes these machines very efficient when you look at something like a power to weight ratio. So since there are many different types of carbon fiber, getting accurate numbers for property specifications is not the greatest, but I'll show you guys the properties of a few different types of carbon fiber that I researched. Those types are called CN60, CN80, and CN90 carbon fibers. So the CN basically just means that it's a carbon-nitrogen mix, and the numbers just show the strength of the carbon fiber weave. The generalized yield strength for all of these is around 3,430 megapascals. Yield strength, for those of you that don't know, is a material's measured stress force before the material encounters any shape change when removed from the stress. When compared to other materials, other more basic materials such as steel, which has a yield strength of 180 megapascals, and titanium, which only has a yield strength of 450 megapascals, you can see just how strong carbon fiber is compared to other stronger materials. And it's almost 8 times as strong as titanium. For Young's modulus values, or sometimes known as the modulus of elasticity, which is just the measure of stress force per strain allowed on the material, CN60 has a value of 620 gigapascals, CN80 has 780 gigapascals, and CN90 carbon fiber has 860 gigapascals. Again, comparing to steel and titanium, steel only has a Young's modulus of 207 gigapascals, and titanium has a value of 107. So again, you can see that carbon fiber has a much bigger value than both the materials. You can also notice that as the strength of the carbon strands go up, as they go from 60 to 80 to 90, and they get closer and closer in weave, so does the overall strength of the carbon fiber material. This is expected when you talk about something like density of the carbon fibers. So as you can see, CN60 has a density of 2.12 grams per centimeter cubed, and then CN80 has 2.17 grams per centimeter cubed, and CN90 has a density of 2.9 grams per centimeter cube. So comparing that to steel and titanium again, steel has a density of around 8 grams per centimeter cube, and titanium has a density of around 4.5 grams per centimeter cube. So you can see the benefit that carbon fiber has over common materials by not only being stronger but more lightweight. Finally, one more property that showcases the difference in the carbon fibers is the ultimate elongation or ductility. So CN60 has a value of 0.6%, CN80 has 0.5%, and CN90 has 0.4%. And all this shows is that the stronger the material, the harder it is to break apart, which that's basically what ductility is. So that would end up making it stronger then. So the strands of carbon fiber are very fine, being about 0.00002 to 0.00004 inches in diameter. So these are big enough to fit thousands of carbon atoms, since carbon atoms have an atomic radius of around 70 picometers, or there's just way too many O's, but it's 70 e to the negative 12th meters. This means that you can fit about 36,000 carbon atoms in a straight line across the diameter of a single carbon fiber. So that's a lot of carbon atoms you can fit in there. But overall, carbon fiber is a modern material that is being used in a variety of different machines due to its strong but lightweight nature. I hope you enjoyed my presentation about carbon fiber, and thank you for listening.